Yes, okay. So I would like to present you with what we have available as a platform that is called the 3D Experience platform, and see what we have available as fluid solution with the platform. So you will see during the different presentations that I will show you today, first, what is a fluid dynamic engineer that we have available that is more than just a software or a tool. It is a full solution based on the role. I will explain a bit what this is, what you can have with it, and how this could change not just the way you simulate, but the way you design your models. This goes further than just the CFD tools. And then I will also explain a bit about the cloud solutions we have available, as one strength of the platform is to be available on cloud so that you can use it without needing to have supercomputers or hardware on your side. You can collaborate nationwide or with people all around the world, as well as work from home, etc. And you can also, for example, use XFlow, as was shown just with the presentation before, onto the 3D Experience platform with the cloud, compute into the cloud. All of this is available. And I will close with a small demonstration of what would a design process be when using the Fluid Dynamics Engineer, when using the platform, and how that could then change what different companies would be using. So first, about the Fluid Dynamic Engineer. This is a role that is available on the Dassault Systems platform. It is 3D Experience platform, and on it you have the capabilities to simulate fluid, to have a lot of fluid simulations, thermal simulations, as well as, of course, structural simulation, electromagnetic, etc. For the Fluid Dynamics Engineer role, this is a CAD and PLM embedded CFD solution for flow and thermal performance simulations, and that helps you accelerate product innovation inside a collaborative ModSim environment. You will see later on what we explain with ModSim, modeling and simulation put together as one environment. So the main advantages that you can see here are the fact that this solution is integrated as a ModSim. We'll explain that a bit later. It is designer-centric, so that designers can use it and are meant to mostly use it. You do not need to have high-end CFD experts having a lot of knowledge and experience. Designers can do it. It is better if you have experts so that they can specify and set up correctly the different models that designers can then use. But designers will use it in the end. It is very comprehensive and easy to start with, has completely automatic meshing solutions, has the cloud capabilities, is scalable with multiple different levels, number of cores, size of the domain, etc., and can help you collaborate a lot inside your company, as it is not just a CFD software, it has a bit more than that. It is the main workflow that we will be using during the presentation to show you a bit how this works. It is based on a motorcycle exhaust example model. It starts with, well, of course, some inputs, operating condition, mass flow rate, temperature, some catalyzer properties, as well as the native CAD geometry. So with the fluid simulation on the 3D Experience platform, you start with a native geometry. You do not need to start with a meshed geometry or a complicated improved model or some fixed done, etc. You start with your geometry as is, and you go with the workflow then with geometry preparation, operating scenario creation, automatic fluid volume extraction and meshing, simulation, post-processing, and then for improving the design, you will see that this is a large topic here. That is, you do not just want to have one validation and that is all. You want in the end to have a good product. So you will improve your design and use a platform to iterate onto it and let the platform help you as much as possible, as in the end, the platform is an artificial intelligence that can really help you make all your design better, faster, more efficient. So first topic is collaboration. Using a platform means that all the people in your company can be on the same platform, on the same place. This is not a file-based system. This is a model-based system. What that means is you do not need to send, download, upload, or change any file. The files are not there. This is all based on models. So you have one model, and on this model you have everything together. All the people can access the right information in the model. Any change that will happen to the model will be updated for everyone because this is the same model that you design. This will lead to some good improvements and automations that you will see a bit later. So with that, all the key shareholders, stakeholders can collaborate on the same model without having to work on with different files, different mesh, different CAD, etc. Everything is linked together. You have one single source of truth. All the information comes from one place. You are sure you do not have the wrong model or the wrong level or the wrong mesh, wrong improvement, etc. Everything is there. All the user access control is role-based so that you can define roles for people and apply, for example, the fluid dynamic role to a specific designer or a specific engineer to say this person is responsible for all the fluid simulations. You do not have any data integrity losses as it is all into the same model, and you can use the dashboards. Dashboards are very simple, lightweight way to review, collaborate, and work together that is web-based. That means that you can go into meetings with your phone or your tablet and have access to all your models, information, results, intelligence, optimizations, etc. The first example about what actually you can access to with the 3D Experience platform. This works either on an installed platform or with a cloud platform. You start with a dashboard that is on a navigator. You just open your navigator. You can do it from your tablet, from your desktop, anything. And you can start working with a lot of collaborative tools. For example, this one that is tasks. So you want to work on the exhaust system workflow. You define a task for it and say, okay, I need to finish it until a certain date. It is in work. I can assign people to it. I can work together. I can share models, etc. At the same place, you have also access to your different models. They are directly inside here, and those are models. Those are not files. So you can look for them, search, filter, make sure that the right information is there. You will not have different copies or anything of that. It is one model. This is the official one that you can review. You do not need to open any software to review it. It is directly available onto this dashboard. And you can also use communities. We have a lot of communities that you can create and work within your company. And for example, post your models or ask questions, comments, etc. directly there. We then have the integrated ModSim. So ModSim modeling and simulation put together. That means that on the platform, on the same place, you have all your models together. The whole model, for example, that you will see on the video here is of a bike. Everything is inside it. And whenever you need to check how it has been done, what has been done on it, what simulation was completed, what validation was done, what improvements, what new revision is ongoing, you can all check it up at the same place and make sure that the right part is done correctly, nothing is missing, etc. Here, for example, it is a platform that you have your whole motorbike inside it. You can just explore it, review it. You have all the different parts separated here. You can go even more into details if you would like to do this assembly, for example, and see everything that is needed inside it. And on top of just visualizing it, you can open it, you can work on it from here, you can use simulations from it, you can use CAD, edit the CAD, you can put parameters, you can assign people, you can comment. You can also, like you will see here, choose a lot of information to view, as for example, has it been all updated? Do you have the latest revisions done? Are they confirmed? Here, this is the case. No old revisions that is still remaining onto it. You can also review what simulations has been done onto it. Here you have some specific parts that have been used by simulations. Others have not been used yet. You have intake, brake thermal, airflow analysis at the exhaust that have been done. The others are not done yet, and you can review them. From there, you can directly click on it and you will see the simulation results, the simulation settings, and really manage your whole product all together at the same place. Anytime you want to do a simulation model update, like a design change that you have, and you want to verify this new design is correct or not, here will be one example. You have your whole model, and you have your exhaust system here where you have a new revision. You have the new design on the right, a design variant that has been created by a designer. You can directly visualize it, replace it on here, your master geometry, and from there you will be able to redo the simulation that have been created that was prepared for validation. Very simple. You just replace your model. It will check what revision is available. You apply the revision and you see then the new model. New model is put onto it. You do not have any validation yet. Simulation has just been done with the old model. But if you just open it with a fluid scenario creation, with a fluid dynamic engineer, everything is already updated. Simulation boundary conditions, mesh, everything is already there and you do not have to change anything. It is automatically updated. You just have to click on simulate again and you see the results for the new revision. You can then check a lot of results, see how it is it better, is it okay, are the KPIs respected? And of course, you can also have access to the previous results because they are also here. You have the previous revision, everything is traced, so the results are also here and you can compare before, after, how much it has improved, is it better, should I change something else, etc. After that, you can go a bit further and use the artificial intelligence to have a design exploration and to really improve your model using the help of the computers. For that, because you start with a CAD system, you can put key parameters onto your CAD. You do not work with a mesh, so you do not have limitations due to the mesh. You can already put parameterized CAD inside it. Have, for example, here, parameters for the inlet, outlet size, the curvature of the ducts, the length, different sizes. You then prepare a baseline, a first setup for the simulation. You have one simulation done. This is your base model that you want to improve. From there, you can define a whole process for the automation. This is done using either a DOE that will look into all the different parameters and gives you results on how important each parameter is, how much impact it will have, so that you can then choose each parameter correctly and also interpolate between them to have, well, the most efficient parameters possible. You can also use optimization and completely let the computer decide for you what parameters you should use. When this is prepared, that is very easy, very quick to do. It's just you put DOE, you put your fluid simulation, fluid setup that you did inside it, what parameters you want to change, and that is all. You can also, of course, here put other simulations. For example, if you do an exhaust flow, you might want to do also a thermal simulation together and a structural simulation also that would need to be done onto the same model. You can put it all together at the same place because it is the same model, everything is at the same place, single source of truth. So the DOE can do all of it together and give you the best design, not just considering fluids, but considering all physics together if needed. Once this is done and the different simulations have automatically been run, you do not have to touch anything here. You will have the performance analytics and trade-off reviews available. And there you will be able to choose which parameter to change, how much to change it. You will have all your results KPI available that you can visualize, that you can explore, etc. And from there you get your best design. You finalize your design on it. It is just one iteration. You do not need to reiterate and come back to the CAD because it was coming from parameters. And of course, your process that you have created for the setup, simulation, as well as for the automation, for the design, the DOE or the optimization process, Those are also elements that you can reuse, you can democratize, you can use on different models, you can put as templates to then make sure everyone can use it, etc. That also means that we have that sometimes where the engineer responsible for a certain part, the expert, is quitting or retiring on the company, and because of that you lose all information on it and you don't know how to do that anymore, or you need someone to learn onto it but you do not have information onto it. This is not the case here because everything is available on the platform, is explained, all the settings are here, the information on each setting is here, the processes are here. You just need to reuse them, and if you want to learn how it was done, you just need to open them, and every information is inside. Here, let's see a simple these simple settings, how it has been set up, how the user interface is working for the platform for the fluid simulation. So here is your model that you have opened onto the platform. Whenever you open the model, you can open the Fluid Model Creation app. This is an application that is available on the platform whenever you have this role. And you have an assistant on the right that helps you define everything. The assistant will guide you from top to bottom to have the correct settings done. First thing you do here is specify the model. Okay, you want to have an internal flow here onto your exhaust, and on the middle you have a catalyst that you will want to use as a porous media. The inlet part, the outlet parts are two main zones. You just select them. The openings are here, but you do not need to close anything. You do not need to change the shape to have just one shell or one solid, etc. Openings are automatically looked at and defined. So you just select the opening, create it as an opening, and you can use that as a boundary condition. You do not need to do anything else. You then can assign the right medium, the right materials. So you assign air, for example, for the inlet, for the inside of the geometry. You can assign the right porous material for the porous media that will be in the catalyst. All the database is at the same place. It is one database put into the platform so that you can control it, you can create the right material, you can have different people, make sure that your material is right, is correct, that you can use it. When the model is ready, you can go into the physics behavior. You will see we have choice into the main physics behavior that you could think of for a CFD simulation. And boundaries, you just need to define inlet, outlet. You have the geometries available. They have automatically been created. So you define the mass flow inlet. Here's the pressure, static pressure outlet. You define for the porous media the zone corresponding to it. It's a porous zone that you have here. So you just define it correctly with the axis that is aligned with it. So viscous resistance, inertial resistance, and once this is done, your model will be set up correctly. Until now, you have seen that no mesh is involved until now. The mesh is the last part, and it is an automated mesher that is available, so you do not need to take care of anything with it. It is just to define everything on the CAD itself, and then the mesh comes into the CAD so that whenever you update the CAD, all the settings will be kept correctly, will be updated, and the mesh will be initialized again, redone with the new CAD automatically. It is here, it is an X dominant mesher. You initialize it from the support, you can change parameters if you want to have something final or not, and then you define simulation. You can simulate it on your own machine. You can simulate it on a server, supercomputer, or on the cloud. You will see a bit later how this is. And during the simulation, you can review the results. You can see how this is converging and have all your insight with that. A lot of physics are available into this solution. So steady, unsteady flows, internal, external flows, incompressible, compressible flows, Newtonian as well as non-Newtonian flows. All the thermal capabilities, including electrothermal, are available. Multiphase is also available, as well as particle tracking and scalar transport. You can have modelings for all the moving bodies as reference frames, fans, baffles, porous media as you have seen. Electronic components models are available as database directly inside it. And you also have the possibility to use human comfort models as well as the mist, the fog models for the HVAC systems. It is using a rounds solver. So this is a Navier-Stokes rounds solution. If you need anything better than round solution, anything more accurate, if you want to do acoustic simulation or go more into details, then you would better go not with Navier-Stokes, but as you've seen just before, go with Lattice-Boltzmann. That is more efficient, faster, and will give you better results in the end. All the main turbulence model like SST, K omega, or realizable K epsilon are available. Spalanceramat is also available. You can define them automatically without having to think about them, as well as if needed, if you're an expert, you can define very fine properties into it, each parameter for each turbulence model, for each define that you have been created, you can define them, of course. The measure is automatic. So you have the main X-dominant mesh available for fluids that is body fitted with boundary layers that are available, that it has a minimum user inputs and interaction. You can define with just one button that is telling you, do you want a coarse, medium, or fine one? How fine do you want it? And that is all. You can also go into details and define it very finely and have each different part meshed differently with your own options. For solids, you also have the possibility to use tetrahedrons or sweep as well as shell meshing if needed. You have all the visualization, review, diagnostics that are available directly, so the assistant will tell you whenever there is a problem, whenever you have missed something or you need to be careful with some parameters, it will tell you before you simulate so that you do not have to lose time simulating something that would not work correctly. Post-processing is also available directly onto the platform. You can also view all the post-processing and do it from your own navigator so that you can bring it to meetings, do it directly in front of other people, etc. All the base post-processings are, of course, available. You can have reports created, you can have KPIs outputted and collaborated with other people, of course. For scalability, you can compute with it with around 60 million mesh size at maximum. It is getting improved to 80 million at the moment. You can use up to 144 cores on the cloud. You can also use more cores if you have more available on your own systems, but for the cloud, it is up to 144 cores. That should be more than enough for any round simulation. Complex geometries are, of course, available, and you can have people using it that could be just mechanical designers even. That is not a problem. You can go more into details with engineers and even go with simulation experts to define your simulation, define all the different settings, and you can have them feed it back to the designers so that the designer, whenever they use this solution again, they will use the right settings from the beginning because assistant will tell them to use these settings from the beginning. As a summary, integrated ModSim is available so that you can very easily explore design alternatives from the early stages. You have your CAD parameters on them. Whenever you change something, the simulation is also updated and you keep all the information before, after, so that you can compare them. It is designer-centric as it is all guided and you have artificial intelligence helping you to define all the right settings and making sure you're not making any mistakes. It is comprehensive as you can use all mainstream flow simulations, thermal simulations that are available. The meshing is automated. It is not a meshless solution, but as it is all automated, you do not really see the meshing part happening. It is available on cloud so that you do not need any infrastructure. You do not need to install the platform or to have a supercomputer or anything like this. You can directly go with on cloud with your navigator, set everything, use a small local workstation or your laptop to prepare the very defined settings or the results and just do that. It is highly scalable. You can put it together with processes including also physics, multiphysics like structure, co-simulations, electromagnetics, etc. And you can collaborate as whenever you have this fluid dynamic simulation available. That also means that you have all the collaborative tools enabled together so that you can collaborate with experts, with different people, with different departments on your own company, making sure that someone can have an overlook about everything to make sure that your design is ongoing well, nothing is missed, everything is updated, etc. So this is for the fluid dynamic engineer role. And let me speak a little bit about the 3D Experience Cloud itself. So for the 3D Experience platform, we have the cloud that is enabled so that you do not require to have a strong hardware on your side or to install everything, to have a lot of people onto it, roles, etc. You can start from the beginning with 3D Experience Cloud. The 3D Experience Cloud is everything put together into one place so that you do not need to have a very complex, huge investment, limited flexibility, and disconnected solutions. You can use everything as once from the beginning. It is on cloud, so that means that people from anywhere can connect to it if that is needed. You can work remotely, you can work on site. Everything is available here. All in one solution with everything supervised, and the operation can be supported completely by Dassault system so that you do not have to do anything yourself. You just ask for it, you get it, you design on it, and that's finished. Nothing else to think about. Some benefits. So fast delivery, easy to install and deploy because it's just on the cloud, you connect to it and that's finished. It's available anytime, everywhere. No IT management needed because all is on cloud. You have, of course, all the authentications that are the latest available technologies on the market that is pushed by Dassault Systems. We have certifications, official certifications, of course, with the latest one to make sure that everything is secured. We have the corresponding license model. Also, for more details onto that, you can contact your local focal point. You can contact Sigma, of course, to understand a bit more about it. Just to be quickly onto it, the unified license model is one simulation license model that you can use for all your physics, as well as automation optimization. So whenever you have, for example, your role, you buy the license for using fluid simulation. You have up to 16 cores available for simulation that you can use for small designs, for your usual work, for testing new simulations, for trying different setups, etc. You can use on top of it tokens that are available for purchase that you will be able to use up to a certain capacity that you buy. And every simulation inside it will be then covered. So you can use up to 32 cores or 40, 50, 60, 100 cores, depending. And anything that needs more capacity, for example, you want to do a complete optimization of one model and you want to have it quickly because you had a problem on your design, you want to improve it. This is a one-time simulation where you will have to have a very strong simulation capabilities as you will have to simulate the models 200, 300 times maybe. Then you can use credits and buy a one-time effort where you use 144 cores to have the simulation as quickly as possible. You can run 10 simulations at the same time. It will cost just for that one simulation that you're doing, for that one project, and that is finished after. For the design exploration, it costs less if you're doing design exploration because you do not have to redo anything. It is all automated and done by the platform using its AI. So you do not have to pay for everything. You pay 10 times less per simulation for your design points inside the design exploration so that you can leverage really all the artificial intelligence available onto the platform to do your simulations without increasing the costs as much as possible. The cloud simulation, what is available? On the cloud platform for the simulation, you have, of course, modeling and simulation together. So that's the first point. You have the scalable on-demand compute that you can choose anytime you want to simulate it. You can choose how much cores you want to use for this simulation. It is connected to the collaborative platform, and you can use it for all physics, all scales. You have structures, CFD, electromagnetics, automation, design exploration, all available there. So the main values for the cloud computing compared to having your own HPC, for example, is when you have your own HPC, you might need to have model size reductions to wait for the cores to be available, to simulate variance every time by hand. You can have trouble with access, with uploading the data to the HPC, downloading the results from the HPC, etc. With the cloud, you can simulate it as is, even if it is a huge complex model. This is not a problem. We have the resources for this. You do not need any output, input, downloading, uploading into it. Everything is available. It meets the compute needs exactly. Nothing more is used than that, and you can access the results from anywhere. So with the cloud compute, you can, of course, solve on your local workstation, even if you have the Studio Experience Cloud platform on cloud. You can then run as many cores as you can on your workstation. You can visualize it locally. You can update it back to the cloud so that anytime someone else wants to see the result, they can access it from anywhere. And you can also compute in the cloud, use multiple numbers of cores, hundreds of cores. You can use GPUs. You have the option between automatic or manual selection, of course. The AI can select for you automatically what number would be best for this simulation, depending on the size and complexity. You can have all the post-processing done on the cloud performance so that post-processing is almost immediate, and visualization available, no need to have limitations on concurrent simulations. You can use queues also for tokens that you have. So examples on what you can use: structures, durability are available. For fluids, the fluid dynamic engineer for the most part of the simulations, as well as plastic injection engineer is also available. Electromagnetics is available here. Some more advanced structural roles like composite structures are also available on the cloud directly. You have the process composer. That is the main tool for using the AI for all your automation, optimization, design exploration. That is available here that you can use for fluid simulation as well as multi-physics altogether. This is one example that I will go through a bit shortly. It is on structures, not fluids, but it shows that you have a certain baseline, a certain design on the baseline. It shows some certain results that are not really optimized. This is not good. You need to change that. You can select design variables that you can change onto it. Use DOE's run that may have already been run onto it, and you have multiple, okay, here, multiple beam height, position of the beam, thickness of the beam also you can add, and you can add a specific results you want to check and you want to see. Here it is a max roof displacement. You need to have it under a certain value. You also need to have certain frequencies, add certain values, and check them. You define it, you define how much design points you want to submit, how much cores you want to use. Everything is computed automatically. It will give you a lot of different designs for it and tell you, okay, I have tested all of those. I have some points here that are on red that did not respect your parameter. And you can, from there, visualize all of them, check them, see which one would be best, which one would be more effective, which one would be cheaper for you, and see the results altogether, see which one has the least displacement or better frequency. For fluids, this can be the best mass flow outlet, the lowest pressure drop, any kind of thermal limitations that you may have, and you just select the best one that you believe is available for you. You can also let the AI decide for you, and you can go with this new design in the end. Cloud computing is also available for XFlow. It is available directly as a dashboard so that you can go with your navigator, have XFlow directly onto your navigator as sessions, remote sessions, prepare your model, compute, get your results, everything onto the platform. And when you compute, you can use up to 396 CPUs, as well as if you want to or you need to, you can use GPUs with up to 4 GPUs usage at the same time. This is also available for PowerFlow. That is our second solution for LBM software, focusing on best-in-class aerodynamics, thermal as well as aeroacoustic solutions. That is also available with up to 1,000 CPUs, all inside the cloud, all done with the navigator, so that you can use XFlow, use PowerFlow, just with your tablet, even your phone, even though I would not recommend it with the screen size, but you can use it directly from there. And lastly, I would like to go to the last presentation that I have here. That is exactly how do you use this fluid dynamic engineer? It could be not the fluid dynamic engineers, but it could be XFlow on the cloud. This would be very similar, but this is an example on how to use it when, as an example again, you do not already have the platform. Platform is a huge tool where you can have the whole company into it, but you may not have the platform at all. You may not have anything to start with. So how could you then use these fluid dynamic engineer roles? How would that connect together? Well, here is the presentation made for that. So this example is based on a thermal system scenario that is for an HVAC customer that is creating its own for the T&M industry. And here is the typical company landscape that you may have or be slightly different, but we would believe that this is the main point that we have. In this example, we consider the company to have a CAD system that is, for, as an example, CATIA V5. This is not the platform. This is the CATIA itself. It could be SolidWorks. It could be other competitors like NX, Creo, etc. This would be the exact same presentation. This company has a certain PLM solution. They may not have a PLM solution. They may have one that can be any kind of PLM solution. And they have some CAE tools, CAE softwares available. They have a team specifically for this thermal problem. So they have this thermal system leader, and then the R&D team, as well as the design team, with then the mechanical designer inside the design team, and the simulation team leader inside the R&D team. What they would like to is innovate, keeping costs low, have a quick feedback to the customers, and have a reliable conceptual design. So they want to, as you've seen on the previous presentation, push as much as possible the design phase for having simulation as early as possible in the design phase, having feedback from it, design studies, good iterations, and quick feedbacks. So that anytime they have a problem, they could use simulation, resolve the problem as quickly as possible, and not lose any time. Then what would be the process as is for this company? And what would be the process if they go with our solution? For a traditional point of view, this would be what we believe as a traditional design, where you have the design that has been made in a CAD system. Here that could be CATIA V5, that could be others. The designer made it. And the designer, when he makes the CADs, want to have its CAD checked to make sure that everything is all right, or if to check what he needs to change. He might have a lot of different physics to check, so he might have to ask different people from the R&D team. He might have to ask for fluid engineers as well as thermal engineers, as well as structural engineers, etc., etc. What he will do is he will send an email or files or links, etc., to all those different people, telling them here is the new geometry that we need to check. You have until a certain time to give all the results. Then this analyst would download the CAD, would do a geometry cleanup from there, making sure that he does not have any part of the CAD that he doesn't want, making sure that all the right parts are in, there is no trouble, there is nothing missing, etc. He might have some trouble here if he doesn't have a very good understanding of the CAD. Or they might sometimes be a different person, not the analyst, but the mesher person or equivalent, taking care of that in between the designer and the analyst. And then you have someone else, a third party that is coming inside and that is, well, making this process a bit more complex. After the geometry cleanup, then the meshing happens. The model is completely meshed. This can be a bit automated. This can be quite a lot automated. This can be completely manual, depending on the solution they have. Then simulation setup is done, solving is done, evaluation, and whenever there is a problem, there is a design change that needs to be done, then this analyst will send all the information to the designer and tell him you need to change this that way, you have this that is not good, this is good, be careful with this. All the feedback is done. Then the designer CAD will have the feedback from a lot of different analysts depending on these models, and will have to work onto it, change his CAD, and resend all the new designs to the analyst back into a second phase. For the 2B, what we believe would be much better as a ModSim approach looks like this. The designer works with his CAD system and where there is no analyst. This is the first main change, that the designer himself should do the simulation. The analyst, what would be his job here? His job would be to make sure that the simulation used by the designer is the right one, has the right KPIs, has the right values, accuracies, etc. So he would work on the process itself, on the simulation process, the setup, making sure that every time it would be a right setup and that the data is correct, and help the designer if the designer needs more understanding with the evaluation part. So the designer himself will work with the CAD. He does not need to do so much geometry cleanup. First, because he does understand the geometry much better. Second, because FMK does not need to simplify so much the geometry. You can use openings as they are. You can use multiple shells, layers, etc. You do not need to take care of all so much details at all. So from the CATIA model, or from the SolidWorks model or any other tools model, with the Power BI, you put the CAD onto the platform. That can be cloud platform or installed platform, and you just open FMK. The model will then be very easily pre-processed for simplification. The meshing will be automated. You will not spend so much time on meshing, as this is 1 to 5 clicks, depending on how fine you want to have your mesh. The setup is done with the assistant that will guide the designer through the setup, making sure that everything is correct. It will also, the assistant can use all the information coming from the analyst to have from the beginning the right settings done. Solving can be done onto the cloud to use more cores, better capabilities, and the evaluation is done. And when the evaluation is done, you want to then have the feedback. But evaluation, everything up until there has already been done by the designer. So no need to have a feedback complex loop. The designer already understands what is good, what is not good, and what it needs to change. And when it changes that, well, then the loop is completely automated. So normal process with as is traditional processes for designing a solution takes weeks. It can be 1, 2, 3 weeks, depending on how complex your system is. And you can do one iteration every few weeks. So if you need to have a lot of different physics together, or if your complex design needs a lot of different iteration for having a right design, you will just not make it in time. And every time you will have to involve 2 to 3 people, work together, have some communication, file base that could be corrupted. They may use some old versions, not the right one. Meshing may have some trouble. The design change may just not be possible because it is not coming from the CAD. It can be really complex and quite a pain to develop anything with it. With a new ModSim approach, this is done in just days, and because the designer is here from beginning to the end, he can do all the different physics together and compare them together inside the same platform. The UI is exactly the same, the process is the same, and iterations, they already know right from the beginning what they can iterate on, what they can change, what they can improve. It is much more efficient. For the actual simulation process, looking at time, coming back to the same way, when looking at the baseline, you will have a few days, maybe a few hours, maybe a day for designer to communicate to the analyst, get all the data and start working on it. You might have data silos with this, you might have miscommunications, trouble with it, delays, etc. Then fluid volume extraction can take some time depending on the CAD that you receive from the beginning. Meshing should not be that long, but can use some time as it is not always really automated. Simulation setup will always take a bit, and then evaluation. And up until that, even just the baseline may take 2 to 3 days to get to that point. And then you want to do design iterations. So you go with a whole loop and you need to contact feedback the CAD designer. That will take some time to change the CAD, send it back and redo everything. You can use some automation into it, but most of the parts will have to be redone. So design iteration might still take 2 to 3 days every time you want to use it, even for small models. With 2B, the difference is, first, the fluid volume extraction is mostly automated. You just define what you want to use and what is your openings, and that is almost all already. Meshing is automated. You just need to wait a bit for your computer to be able to completely do it. Simulation setup is just one assistant that you follow up. Sometimes you might have some difficulties with the simulation setup if you want to define very specific, very complex settings. But even at that case, a couple of hours maximum. So one baseline would take somewhere inside a day, maybe 1 day, somewhere around that, nothing more. It is quicker than the traditional one because the designer does it and uses the platform to have it automated. Everything is linked together, everything is there. And design iteration, the only thing you need to do for design iteration is get back to your CAD, modify what you want to do from the CAD, re-upload it with the right connection, saying this is a revision, and click on the Update Simulation button. And that is all. So 1 hour and you have your design iteration. And you can go on with this loop much faster. You do not have any risk of miscommunication, any risk of something not being correctly set it up, something not being correctly done, any needs for downloading files, for having the wrong file, for getting back with solutions that are not applicable, etc. Of course, inside that, the analyst can access any type of information inside it at any time. He can check the setup at any time before, after the simulation, come back to it, iterate on it, change something on the solution, get to the evaluation and help the designer with some information there too. All is on the platform, available from Navigator, with collaboration, with a lot of tools to communicate directly from there, so you can put annotations, information everywhere. A small video for actually doing it. This starts with CATIA V5 here as an example, where the designer that uses it just has to save the CAD to the 3D Experience platform. Then, opening the platform, he opens the same problem. Here, a small change that needs to be done is this design was extremely fine, and you don't want to use that for your simulation, as you just want to set a porous media instead of that. So what you do is, well, just a small change. The small change is done from the CAD system, and the designer does it, so he knows how to do that and can be very quick with that. You just, like this, do a very small shape, make it a box instead of having this very complex grill, and that is done. You then open it into the fluid model creation, fluid dynamic engineer. You see the exact same thing, the UI is the same, it's just that you have the assistant, everything ready on the right. And then fluid domain, you select everything, you make sure it is inside the flow that you want to simulate. All the openings are set it up very quickly, very efficiently here. And you can go with porous medias. You have your 2 porous media that you can set up. Put the material inside here. You're sure everything is checked up on the platform. The mesh is automatic. You just need to say, okay, I want this size of mesh, that should be good. You can even let the AI decide for you the size of the mesh that would correspond. And once you've done this, well, you already have your mesh ready, everything is ready, and everything is getting simulated. When simulating, you can choose, do I want to do it on cloud, how many cores, local, do I want to use credits, tokens, etc., and the simulation just goes. Results are available on the exact same interface, exact same UI. You can create sensors, you can create KPIs from there, or even beforehand, if the analyst already prepared that for you, you can just read that. And you can use a lot of communication tools. You can use change actions, 3D markup, where you put a small markup about what you want to change. Okay, you would like to have a change like this to improve the model. You can then go back to your CAD. You can also do that from the platform if you're used to it, and just do the small change, re-upload the data as a revision, open your revision, put the new one. You can compare them if you want to. If you want to make sure everything's correct, your manager can come and just compare the revisions if he wants to. And once you have the revision inside your model, you just click on simulation again. All the mesh, all the settings are kept and done automatically, and you have the results, new results. When you have the new results, you also have, of course, the old results, the old revisions. All of them are available, so you can just open it from your navigator, check which one is best, what KPIs you have, how much that changed, which one you should use then in the end, has it been validated or not. You can check all of it, you can export it, you can create presentations for this, you can post it on the community. All of it would be available automatically. So just the conclusion of this presentation, that you might have already a CAD system like CATIA V5 or SolidWorks, NX, Creo, or others. We have the Power BI to connect it to the 3D experience, so that if you want to use the platform for cloud computing, for putting XFlow into a very easy way to use it, for having all your database checked here for communication, or for using the Fluid Dynamic Engineer, just need to connect it with Power BI and use the 3D Experience Cloud, and that is all. You do not need to buy anything else, to install anything, to have complex IT. This is all done directly here. FMK, this is a name for the Fluid Dynamic Engineer, is a generic CFD solution that is validated against all other main well-known CFD solutions. It is the best in class for specific simulations. It is on par for all other simulations, can be computed on cloud. It has a high value as designers can use it directly. People can connect together. Your process itself will change. This is not just a tool, but this is a whole solution together with the platform. Volume will be much faster because every variance, every change can be done much faster and checked together. You can also have much more advanced designs thanks to use of AI and design iterations. And in the end, reduce the time to get a simulation results by 5 to 10 times looking at the whole simulation itself. So from the beginning, architecture phase is get faster, concept design much faster, simulation is used from the beginning, detailed phase get faster, and you can finish with your physical test quite earlier than before. And here get to the end of this presentation. Thank you very much for listening to it, and thank you for